Hi all. See this, in this particular problem we are need to find out the limit n tends to infinity and all that stuff, right? But surprisingly, right, this is not a limit problem. Surprisingly, this is not a summation problem and all that, or product, whatever, right? It's a problem actually from integration, okay? So let's see that how we apply integration to calculate this, okay? So first of all, we just concentrate about that particular limit. See that it has some particular numerator and denominator, right? So therefore, we just consider this is a and the denominator as b, right? So therefore, we can say that fx is equal to a by b form, okay? And the remaining is straightforward, where that a is equal to the numerator and b is actually the denominator, okay? So we can consider that, okay? Now, our job is to simplify this, okay, because then only we are able to rewrite that in a or find the value in using the integration, okay. Let's go ahead, okay. Now see that if I consider that first a, okay, now here our main job is to find the general term, right, so that we can write down that as a product of everything, okay. Now see that here we can take n common from that first term, that x plus n, we'll take n by 2 common, we'll take n by n common, so that we'll get it as 1 plus something and so on, okay. Let's go ahead with that. So if I expand that, see that here we take n plus n by 1, so n taken common, n by 2 taken common, n by n taken common. Now notice that how many terms are multiplied? The number of terms is multiplied are actually n number of terms. Now as n number of terms are multiplied, so it will be n to the power n, right? So we'll have n to the power n to the power n here, and in the denominator we have one term called 1 into 2 into 3 into n, right? And the remaining all the parentheses or the that open bracket all are multiplied. So let's write down that. So if I go ahead, we write n to the power n divided by factorial n. Obviously here I don't write factorial n, all the product and the remaining thing, right? Now n to the power n and n to the power n, that product gives you actually n to the power 2n, right? So let's write down n to the power 2n, and here we have factorial n, okay? So let's go ahead. So therefore, this can be easily simplified as n to the power 2n divided by factorial 2n and the remaining product, right? Now we all know that what is the use of or how we write the summation, okay? Now that summation notation, and we write down, so it's that all the n number of terms are added. We can have some symbol called product, okay, a big pi kind of symbol that actually interpret the product. Let's see that how can we write. So here r is equal to 1 to n, here you see 1 n 2 3 4, so this is r actually, so rx by n plus 1 gives you a simple way of writing a, okay, and the symbol used here, the big pi kind of symbol, right, that actually states here the product. So this is a product symbol, okay. So a is simplified. Now our main job is to simplify the denominator, okay. Let's go ahead and simplify it. So now for the time being we just forget about a and try to simplify the b. Let's go ahead. So here we just go ahead and simplify the b in the same approach, okay. So here we just write down as 1 plus something, so here we'll take n square common, then 4n plus 4 by n square common, so that where we'll get one term, right. So let's go ahead. So if I go ahead and take all those things common, right, and rewrite that in the similar way we already explained as in a, we'll say that it is n square will be common because all n square, so n square whole to the power n taken common, and here 1 square, 2 square, 3 square, 4 square and n square will be common. So what's that? You can see that it's 1 into 2 into 3 dot 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 to n whole square. So that means it is factorial n whole square. So therefore we can write down as n to the power 2n divided by factorial n whole square. But surprisingly we are having factorial n is multiplied. Now as the factorial n is multiplied, right, so therefore one factorial n can be cancelled and it can be written as n to the power 2n divided by factorial n, and everything product will be written as r square x square by n square, because that's the general term. So now we are able to simplify what is a and what is b. Okay, now what we are looking for, we are looking for a by b. Okay, so what is a by b? This term get cancelled. See that we are having n to the power 2n factorial n common, so that's we don't bother about, and obviously it's a product, right? So therefore we can think of that this term is divided by the second term, right, this term, right? So each term can be written as separately, right? So that's why that fx can be now written as limit n tends to infinity, that's common, pi will be there, and rx the denominator and numerator is there and whole to the power x by n. Okay, so that's the very old simplification. So this is the first job. Okay, now whenever it's done, right, we now look for that taking a log. Why? Because product always gives you a problem, right? So how we make that product to all that items are product, so that product can be converted to summation by taking log, right? So we'll take natural logarithm ln for both sides. So if I take the natural logarithm, it's become ln fx, and x by n will come at outside using the power law from each term, and each term this summation will be converted to summation, right? Because it's a product, so we'll have log ab is equal to log a plus log b. So using that we can go ahead and write down in a summation notation. So now we can see that this is my notation. So now let's play with one line extra. I just considered 1 by n inside the limit. Okay, why? Because here n is tends to infinity, so technically n should be inside, right, not outside. Okay, so if I apply the power law, right, we have to take care of that. So forcefully I made a mistake here, so that we need to explain that if I write down that we cannot go ahead, because here this n term is actually outside the factorial, outside the limit, right? So this n, this is not possible, so that's why you need to write down always inside. Okay, that's it. Okay, now look carefully. Now we all know that using the integration chapter that how we rewrite the summation in a integration form. So wherever we had a limit n tends to infinity and have a summation, if we have r by n term and all that stuff, then we can replace it some variable, right? So therefore using that we can easily write down that this is actually equal to limit 0 to 1 log of r by n will be replaced by y, r by n, so it is y square, so it gives you xy plus 1 divided by x square plus y square dy, right? So this gives you my integration, and as it is r equal to 1 to n, so that's why the limit is 0 to 1. Okay, so that's it. Okay, is actually you can see that the remain sum, right? We already learned that in our NCERT book as well, that how we rewrite that summation into integration or integration into summation, right? So we use that concept here as well, right? Okay. Now here notice that here x is not variable, okay, in that particular integration. In that integration my variable is y, so we have to solve this integration assuming x is constant. Okay, that's it. Let's go ahead. So here we just consider the transformation t is equal to xy. So therefore here that this integration can be changed by dt equal to dy, x dy, and when y equal to 0, obviously those are basic step that t equal to 0 and y equal to t equal to x and all the stuff. Okay, okay, so see that now here we convert it to y equal to 0 t0 and y equal to 1 t equal to x, right? This is a normal integration technique. So therefore my given integration is reduces to log of fx, and that's equal to 0 to x log of t plus 1 and dt. Okay, we obviously know that there's transformation, right? Now here we need to apply one new technique that's called Leibniz rule. Okay, Newton's Leibniz rule, or you can see that as the differentiation of a integration or differentiation under the integration sign. Okay, so if I do that, think on that. If I apply the Newton's Leibniz rule or the integration under the differentiation sign, we'll say this is became 1 by fx and f dash x, and this x go inside. So therefore directly we can say that f dash x by fx is equal to log of x plus 1 and x square plus 1. So the total summation that fx now reduced to a very simple easy calculation. Now let's go ahead and see that. So f dash x is equal to fx into log of x plus 1 divided by x square plus 1. So that gives you the problem actually. Now from this situation we have to understand that which options are correct, right? So we calculate fx and f dash x in a very simple form, but still we are unable to say that which one is the correct option. So that's why we just take that only that relation, right? That f dash x and fx we already proved it, right? Now you can already see that this is log x plus 1 x plus square, so we can apply log a by b is equal to log a minus log b. So that's why we can expand it as in this form, right? Now see that why I am doing so, because our job is to find which value is greater than. So if I am able to understand that fx and f dash x, which is an increasing decreasing function and all that stuff, then it is easy to get all those decisions, right? That's it. So now you can see that in the interval x is 0 to 1, x and x square will be changing. changing, right? So if x is less than 1, right, x is greater than x square, and if x greater than 1, x square is greater than x. So these values also will change its sign based on that. So therefore we can say that between that x equal to 0 to 1, that interval, right, x is greater than x square and x square is less than x. So if I add both side 1, the same equality holds good. Now log is become an increasing function. Log x is an increasing function. So therefore we can say that log x plus 1 is greater than equal to this in this interval, and so on. Okay. So obviously we can understand that between 0 to 1 interval, f dash x is greater than 0. Why? Because it says that it says that in our case that fx is always greater than 0. Why? Because it says that x is greater than 0. If x is greater than 0, all the values, it's a natural number addition or product, so we cannot get a negative number. So therefore we can say that this will gives you always a positive number. So that's why fx is greater than 0. So whatever the case for all x greater than 0, fx is greater than 0. So therefore the change of sign of f dash x depends on this one. Now we already understand this case, right? So therefore we can say that 0 to 1 f dash x is greater than 0 because this difference is greater than 0, and other case less than 0. So it's a decreasing and increasing function. So that's it. So these are the definition of the conclusion we make from this expression. Now we'll think of that. Now see for the option 1, okay, or option A. It says that half and 1. So what is greater than? We'll say that half is less than f1, right? Now as we are considered that between 0 to 1 closed interval, fx is an increasing function, so therefore 1 by 2 is less than f1, right? That's a very normal approach. So therefore this is a wrong options. Come back to the second thing, right? In the second case we find that 1 by 3 is actually less than 2 by 3 because 1 by 3 is smaller, 2 by 3 is greater. So it's an increasing function. So again that relation is holds good then, right? Though here it is should be less than because it's a value, right? It cannot be equal, right? So therefore this is the correct answer. Okay, let's go ahead and for f dash 2 is less than 0. So what is f dash 2? See that f dash 2. So therefore here say that if it is x belongs to 1 to infinity, then f dash x is less than 0. So 2 is obviously belongs to the interval 1 to infinity. So therefore f dash 2 is less than 0. That's why it's again a correct answer. So this problem are having at least 2 correct answer currently. Let's check for the last one. Okay, now if I see for the last one, right, they are asking for this f dash 3 and f3 ratios. We already calculate this f dash x and fx ratio, that is log of that, so we can able to calculate that. So here we substitute 3 and 2. Okay, so if I substitute 3, we'll get it as log 2 by 5, just normal calculation. If I go and substitute f dash 2 by 2, okay, f dash 2 by f2, then we calculate it as 3 by 5. Let's we need to find out that which one is greater. How to easy find out? Let's take a subtraction. So the subtraction gives you log of 2 by 3. Okay, see that it is log 2 5, log 3 5 just subtraction. So we can apply that as log a by b form. So therefore 2 by 5 multiplied 2 by 5 multiplied by 3 by 5, so 2 by 3. Now 2 by 3 is less than 1, that's why log value is negative. Now as the log value is negative, so obviously see that f dash 3 by fs3 is actually greater than of that. So therefore we can say that this option is again a wrong option. So therefore for this particular problem, option B and option C are both correct. So that's it. Hope you understood the problem. Thank you.